Okay, so today we're going to learn about three variable systems. And so the difference between three variable systems and what you've been doing today and yesterday is that now you're going to have an x, a y, and a z. So really we're thinking about these things in a three-dimensional plane where this might be your x-axis, this might be your y-axis, and this might be your z-axis. And we're going to have all these different points, and they're going to intersect. Most of these form planes, and at some point you have all three of these planes intersect. Okay, so they're not the easiest thing to draw. I don't do the best job of drawing them, but solving them off, the nice part is we don't have to graph them. We can use elimination or substitution. So let's look at one of these three variable systems and look how to solve it. Okay, so here is our three variable system, and when you look at this you might go, this looks pretty complicated. And the nice part is it's actually really similar to what we've been doing. It's very similar to the elimination process, except now instead of just doing it once, we have to do it a total of 3 times to try to get down to one variable. So here's your first step, and it'll always be your first step. You want to eliminate one variable so it will look like something we've done before. So we want to eliminate one variable. And when we eliminate something, we want to pick that variable that looks the easiest to eliminate. And in this case, I'm going to eliminate y probably would be the easiest thing to eliminate. When you look down, they're all 5s, so they look like the easiest way to eliminate. So we're going to eliminate y first. And let me just label these equations. So we'll call this equation 1, this one equation 2, and this one equation 3. To eliminate y, as I said before, we're going to have to eliminate it twice. We're going to have to eliminate out of these two, so 1 and 2, and then eliminate it out of 2 and 3. So I'm going to take my equation 1 and my equation 2, and I'm going to try to eliminate y out of it. Unfortunately, if I add it straight down now, I have a negative and a negative, so I'm going to just flip the signs on all of equation 2. So it will kind of work out nicer. And we're just going to add. I'll get negative 5x. That goes away. I'll get negative 9z. And then I'll get negative 17. Okay? And this is one of my new equations. And we're going to need 2 new equations to kind of do elimination one more time. So we used equation 1 and 2 to eliminate. And now we're going to do the same thing but with equation 2 and 3. So I'm going to do the same thing but with these two now. So when I do that, I'm going to have 4x minus 5y plus 4z equals 19. X 5y minus z equal to negative 20. These again will cancel. I'll get 5x plus 3z is equal to negative 1. And this is going to be my second new equation. And notice in my 2 new equations that we've got, we have no y. We've successfully eliminated y. After you eliminate y, you're going to take your 2 new equations. So we're going to take our 2 new equations and do elimination one last time. So we're going to have negative 5x minus 9z equals negative 17 plus 5x plus 3z equals negative 1. We're going to add these two things together. That will cancel. This is going to give me negative 6z, and this will give me negative 18. And now I found what z is, which is 3. Once you've found what z is, we can now find the other variables by repeatedly plugging them in. So again, your first step is pick a variable, take equation 1 and 2, and eliminate both of them. Get 2 new equations. After you get 2 new equations, you will then use elimination. Then after you use elimination, you will have a number that you solve for, and to find the other ones, we'll just plug them back in. So I'm going to plug that z into this bottom equation right here. You get 5x plus 3 times 3 minus 1, equals negative 1. That'd be 5x plus 9 equals negative 1, minus 9 minus 9, 5x equals negative 10. Divide by 5, x equals negative 2. So now we have z equals 3, x equals negative 2. And now we will take these two things and plug them into one of our original equations. So I'm just going to write what we had before, which was z is 3 and x is negative 2. Z equals 3 and x equals negative 2. And we'll plug it into one of the equations. I'm going to pick this equation because it looks the nicest. So when we plug all that stuff in, we would get 4 times negative 2 minus 5y plus 4 times 3 equals 19. That'd be negative 8 minus 5y plus 12 equals 19. That would become 4, so negative 5y plus 4 equals 19. Minus 4, negative 5y equals 15. Then divide by negative 5, and y will equal 3. That would be my final answer. It'd be x is negative 2, z is 3, and y is, negative 3. Because 15 divided by negative 5 is negative 3. Okay. So you can see that this process took a little bit, but it actually would be the same thing every time. So take the first two equations, eliminate a variable, take the second two equations, eliminate the same variable, and then go through and keep using the elimination process. Try the different problems today. If you get stuck, please ask.